Hey everybody, welcome to the Smash News Network, least busted name in news. It's time to do another cosmology segment. Make sure you check our playlist for other cosmology videos if you're into the origin and structure of objects in space, especially on large scales. YouTube.com/smashamash/playlists has all kinds of features besides our regular everyday content. So the Webb Space Telescope is about to launch. It's the most sophisticated space telescope ever put into space, and it costs about the same as 5 aircraft carriers at $10 billion. It's a joint project by NASA, the European Space Agency, and the Canadian Space Agency. So we should be expecting to see, shall we say, interesting data coming from the Webb Space Telescope. The James Webb Space Telescope, the largest and most powerful telescope ever launched into space, featuring a tennis court-sized sun obscuration panel. And let's take a random number here. By the way, that article was on SciTech Daily. I'll scroll it back up here. If you feel like pausing the video to read the article, feel free. Again, it's from scitechdaily.com about the James Webb Telescope. Should be exciting to all of you cosmology nerds. Today's random number is 879, which coincides with a catastrophic variable known as HR 7275. And it's a fairly consistent but slightly variable X-ray source here, as you can see in the 16-year graph up on the right. And down here's a 30-year graph. You can see a bit of a cyclicity going on there over the past 30 days, certainly. And let's take a look at this visually. So here it is in ultraviolet. This is from the Galix. That's ultraviolet light, giving us ideas as to plasma structures. And we'll also take a look at this in visible. So here is bands Z and G from Pan-STARRS, a very high-resolution optical survey. Great view of that catastrophic variable. And here's another one, the DSS colored. You can see a bit of an oblong nature to that. The crosshair is not perfectly centered on that catastrophic variable. And let's take a look at it in infrared light. Here it is on the 2MASS, the thermal emission spectra of that catastrophic variable. Again, that's known as HR 7275. Today's, quote, random, and quote, object and catastrophic variables are naughty stars. And there are a bunch of papers that came out about this in the mid-2000s. One actually came out this year. If you want to go check that out, again, that's number 879 on the Neil Garrels Swift-Bat X-ray Observatory transients page. Number 879. Catastrophic variable. I don't like that. HR 7275. And that's the CDS portal there. You can link to that from Simbad by clicking that link right there at the Neil Garrels transients page. Next, the astronomy picture of the day, which is Stephan's quartet, 4 gravitationally associated galaxies, including 3 semi-spirals, as well as an elliptical galaxy. They're all gravitationally associated, folks. They're probably affecting each other's shapes and so forth. Stephan's quintet actually is what it is. There is another galaxy if you zoomed out to the upper right of this image. Anyway, that's the astronomy picture of the day. Makes for a great desktop. And you can go find it yourself if you like at apod.nasa.gov. Let's talk about the water binary. Yeah, it's the water fountain binary. Why? Because there's water showing up there. Now, this is a binary system. And while we can't resolve the individual stars at the middle of this, they're interacting in an interesting way. They are producing one jet which is oriented a bit toward us, which is this blue jet here, and another jet which is oriented mostly away from us, that red jet. And that's from another SciTech Daily article here. This is talking about shared envelopes. So when stars get close to each other, they have a tendency to share their plasma environments. Their gravity interacts, creating a Lagrangian point in between the stars, and that is the location where we see plasma emissions. So this is one of the reasons why Cygnus X3 is so bright. If you've ever seen our previous cosmology segments, we talk regularly about Cygnus X3, one of the only known cosmic ray point sources. W43A lies about 7,000 light years from Earth. It's the water fountain system. Quote, thanks to ALMA's exquisite sensitivity, we're able to detect the very faint signals from several different molecules in the gas ejected by these stars. When we looked closely at the data, we saw details that we weren't really expecting to see, says Theo Khoury. These stars are believed to have ejected nearly 50% of their total mass as a result of something to do with their interaction. So perhaps you'd like to read this article also. This is on scitechdaily.com. Another interesting cosmology entry here. Reference observational identification of a sample of likely recent common envelope events. So several common envelope events were studied here, and probably some very interesting nebulae indeed. In those, let's link to the paper real quick. We'll accept all cookies. One of the most poorly understood stellar evolutionary paths is that of binary systems undergoing common envelope evolution, when the envelope of a giant star engulfs the orbit of a companion. So you can link to that right from the article there at scitechdaily.com. The title of that is Sweet Embraces of Stars with Far-Reaching Consequences Revealed by Gigantic Telescope. Keep in mind that's an artist's rendition of what perhaps is going on around the core of that system there, known as the water fountain system. A very interesting system indeed. And one more thing about cosmology, folks. We occasionally post stuff at smashomash.com/smashteam regarding cosmology, not just heliophysics. If you weren't aware of the Parker Solar Probe's recent exploits, perhaps check out this video. It's pretty interesting in that the Parker Solar Probe has entered the sun's atmosphere, yes. So you may have heard about plasma switchbacks happening. It turns out there's a point where the solar wind particle exceeds the Alphen waves. So Alphen waves are magnetic waves which are constantly undulating inside the sun's atmosphere. And when you exit the sun's atmosphere, the particles are moving faster than the Alphen waves. So this recent video here from the Jet Propulsion Laboratory is talking about how the Parker Solar Probe has already touched the sun, in that it's entered its atmosphere, the area where the Alphen wave speed exceeds the speed of the solar wind particles. Pretty important. You can find the post at smashomash.com/smashteam. That's yet another cosmology segment. Thanks for tuning in. Congratulations on realizing the channel exists. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, least busted name in news.